Hello everyone, and welcome back to the tutorials for AVL. In this tutorial, we're going to discuss another file type that AVL uses for its analyses, and that is the mass file. So what we will go through will be the definitions of the mass file, and we will be using the same graphical user interface that we introduced last time, Aero console, and we will revisit the geometry file that we had last time, and we see how the geometry file and the mass file can be connected, how to set it up, and how we can use it in the AVL to load and run some analysis. So the mass file, which will end with a .mass as an extension, will use point masses and inertias. And it will also help with the overall mass distribution for the geometry or the body that you will be analyzing and you have defined or designed in the geometry file or the .avl files. And it will help you achieve some estimation for center of gravity, the inertia matrices, and additional information you may need for stability analysis when you're running the mass file, the geometry file, and the run files all together in the AVL environment. So this is the AVL geometry that we discussed last time. If you pay attention to the dimensions here, I have gone back and corrected these dimensions and updated the geometry file so that we can have a meaningful design that does not have the horizontal stabilizer and the vertical stabilizer bigger than the wing. So these dimensions are the updated dimensions and they make more sense compared to what we had last time. This is what we will be using when we go through the distribution of mass today, and we will be implementing that mass distribution for this geometry file that we will be working with. So if we have this geometry file and now we mirror it against the fuselage center line, we get a symmetric aircraft design. Now, to make it more suitable for what we need to do, which is to distribute the point masses along the fuselage, wing, and horizontal and vertical tail, to replicate a mass distribution for this aircraft geometry that we have designed, we're going to get rid of some of these arrows and numbers or dimensions. So the design looks a little bit cleaner. Now we need to add these point masses. The purple dots that you see on this design are the point masses that replicate or represent the mass distribution for this aircraft geometry. Now, of course, if you have more of these point masses, you will have a better accuracy or a better representation of how the mass is distributed over this aircraft fuselage or body. However, the more point masses that you have, you will have to define them, so it will create more work for you in the design. And sometimes if you have a simpler design, you don't necessarily have to have as many point masses as you may think. So it's a good practice to start with less number of point masses to represent the mass distribution for your aircraft or design. And if you see that there are inconsistencies, or if you see that there are irrelevant results that you're getting for your analyses, you can start making these point masses finer or introduce more point masses along the body, so you will get a finer distribution for the mass for the body that you're designing. Now, we have dimensions here as to how we have distributed these point masses. In addition to what we already knew about the dimensions, I've added some additional notes that each of these point masses is equal to 5 kilograms. So that means that there is 5 kilograms concentrated mass at any of these purple points that is replicating or representing the mass distribution for this body. Additionally, this aircraft is symmetric, so whatever we have on the left-hand side, we should have on the right-hand side. Something to keep in mind is that in the AVL geometry file, you were able to only define half of the aircraft and then mention to the AVL that your aircraft is symmetric. So AVL would create the other half for you. However, for the mass distribution, you cannot do that, and you have to recreate all the point masses manually. You cannot duplicate about the center line for the aircraft fuselage, for example. That's why, even though the aircraft is symmetric, we do have all the points or point masses, but we only have the dimensions for half of this aircraft. So we know that for the other half, the values will be just changing sign about the x-axis, but everything else remains the same. And remember that the x, y, and z, or the coordinate system, remain the same for the mass file as they were for the geometry file. So that makes it consistent as you're designing your aircraft and then defining the mass distribution for the same aircraft or body. Now, what is the structure of a mass file? We discussed the structure of the AVL or geometry file last time. Now, how would you describe or define a mass file for your aircraft? Similar to the AVL geometry file, the mass file has a header. In addition to the header that will include some main points or information for the mass file, it has additional section for gravity and density information that will basically help you reduce the workload in the command window of the AVL that you have to provide when you're defining your geometries and you want to add some analysis to the bodies or geometries that you have defined and designed. The next most important part of the mass file is the mass distribution, which includes the masses and inertias. Now, the inertias themselves are optional to include, and as it is mentioned in the help file for AVL, the finer your distribution is, or the more point masses you have for your mass distribution, the less important the individual inertias of each point mass become. So you will have a collection of these point masses and how they are distributed. So you see that you can have a collection of these masses and inertias, each of them representing one of these purple points, and you can distribute these purple points anywhere on the design that you have. Particularly pay attention that here in this design we do not have a fuselage because of the complications that are existing in the AVL design and coding. So we only have a wing, a horizontal tail, and a vertical tail. But still we do have point masses along the fuselage to determine or define the mass distribution overall for this aircraft. We are not leaving 0 point masses on the body or the fuselage to be able to capture a proper mass distribution for this geometry. And as you can see, each of these point masses will have its own section or its own line that we will look at shortly, that how they will be defined as you are going to create your point masses for your geometry file. So how it looks in code. If you look at the mass file for an AVL, this is the overall structure of the mass file. So at the top, you have the header section, which includes the units for length, for mass, and for time. you have the gravity and density section, which will basically help you to save time during runtime, or when you're running your analyses, you don't have to type them again and again. And finally, the mass and inertias. And each of these lines will include a mass and inertia or a point mass properties that you define overall for the body or the aircraft that you have designed. So as you can see, each of these point masses has multiple properties. One is the mass. So in this example, we said that we are going to have all the point masses as 5 kilograms. Remember that the unit is in kilogram here. So we have 5. Each point mass also has a coordinate, which is x, y, and z. The x, y, and z are the same as they were for the geometry file that you designed. So the coordinate system is exactly the same. Now, all the other elements, which are the inertias, so Ixx, Iyy, and Iiz, and the Ixy, Ixz, and Iyz are the inertias for that particular point mass. If you leave them 0, or if you do not include them in the file, the AVL will use the default value for them, and it should not make the design that you have or the files that you have corrupted or interfere with the analysis that you are running unless there are particular or massive differences between the inertias of the point masses that you are including. For example, if you have a much larger point mass at some point and it's not really symmetric, so you do have different inertias for it. So if you don't include those information particular to those point masses, then obviously having them all set as a default will have a different outcome as if it was defined properly for each particular point mass. And also, for a point of reference, you can use the comments, which anything that is starting with an exclamation point or a hashtag is considered a comment or a line or a piece of information that is not computed or analyzed in any of the AVL files. So you can use them throughout your files to be able to add comments or descriptions to your files for better understanding or for future reference. For example, one way you can use them is at each line that you're including a point mass, you can also include which point mass in your overall design this is referring to. And this will help you later on as you go back to your designs to be able to find which point mass is representing which part of the overall design and help you find, refine, or adjust the point masses that you have created. So we went over the overall structure of the mass file. We went over how they look or how they should be formed and how they look in the code. Now, from what we went over earlier, which was the design that we originally had and then we corrected in the AVL geometry, and now we added some point masses to, what we would want to do is we want to see if we can create a mass file that will help us create this mass distribution for this aircraft that we are seeing on the screen, which is basically the same aircraft that we designed last time, but now we need the mass distribution information for. So if we go to AVL, and if we start a geometry file or the geometry designer, you see I already have the test file, which was the geometry file. So if I load the geometry file, you can see that the geometry is now refined, so it is corrected to what we see on the slides. And we will be designing the mass distribution for these dimensions or this aircraft geometry. So I'm going to clear this and I'm going to load the mass file. This mass file is what I've already created. So I will be using this mass file to just go over how we created this. So I'm going to change the view to only text because there's nothing we can see on these editor previews for the mass file. And we can see the full mass file created for this aircraft. So we see that at the header section, we have the units. They are the meter, kilograms, and seconds, the defaults that we have. We have the information for the gravity and density. So this is the second section that we have in the mass file. And then we get to the masses and inertias that we need to define. Each of these lines that we are looking at is representing a point mass on the design that we saw on the slide. Now each of these has its own coordinate. So for example, the first point mass is the one at the very front of the nose. So we are setting this point mass to be at 0.000. And we said all of them are 5 kilograms. So this point mass will be 5 kilograms and its coordinates will be x0, y0, and z0. We do have the I, x, y, and z as inertias, but we have set all of them to 0. Because the distribution for all of these point masses will have the same properties except their coordinates. So we are asking AVL to use the default values for all of them. Otherwise, if we do have the point mass specific calculations, we can include the I, x, y, z and the other inertias for each of these point masses to be more accurate in our design or the mass distribution definitions. Additionally, I have added the comment at the end of each line to show which particular point mass that particular line is referring to. So, for example, the first few are for the fuselage, then we have 2 for the right wing, 2 for the left wing, and 1 for the right horizontal tail, 1 for the left horizontal tail, and 1 for the vertical tail. For every coordinate for every point mass, you can just cross-check the design and the dimensions we have put here, and go back to the lines and double-check those as well. So going back and forth between these lines and the design that we have on the slide, we should be able to fully recreate these for the aircraft or the mass distribution that we have. Something else to keep in mind is that, as I said, you cannot use the mirroring option or the duplicate option that you had in the geometry file. So here, as you see, I have created one point mass for the left horizontal tail, and I have created additional one for the right horizontal tail. And as you see, their y coordinate is just changing the sign. So one is 0.25, one is -25. And everything else, so their x is the same and their z is 0. The only thing that has a non-zero z coordinate is the vertical tail. And everything else is having the z coordinate of 0. So this will create the mass file that we have. For the density, just remember that the value you choose is going to be the value you need at whatever altitude you will be running your simulations or run files. So this value, for example, is at X kilometer above sea levels. You have to see what that kilometer is for the calculation of density. If you're at sea level, you could be using the 125 or any other value that is relevant to the atmospheric conditions that you have. Now that we have the mass file, let's see if we can load it in the AVL. So I'm going to save this mass file. And this is called test. So the file that I'm saving is test.mass. If I go back to my AVL console, here I can, as you can see, I need the mass command to load the mass distribution file. So I'm going to type mass, and the name of the file I need to load is test.mass. When I press enter on the keyboard, what this should do is this should load successfully the mass file that I just created and we have reviewed. So when I press enter, you see that this says mass distribution red. It gives the total mass of 65 in units of kilogram, and it gives the reference values of XYZ000, and it also gives the center of gravity for this design or mass distribution. So from this distribution, we can find the center of gravity for the aircraft design that we have. Additionally, it gives us the inertia matrix for the aircraft that we have just defined the mass distribution for. And as you can see, this is a symmetric distribution. And the other important thing that you can see is that the non-diagonal elements for this distribution matrix are much smaller than the diagonal values. This is why when we're dealing with the symmetric designs, we are able to neglect or omit the non-diagonal elements of the inertia matrix, which will help us with the analyses that we are doing that includes the inertia matrix. And this basically is the main file, how to set it up, how to read it, and how to relate it to the design and the distribution of the point masses you have for your geometry, and what are the information that you're seeing on the screen when you're loading the file. Again, the mass distribution file is mainly used when you're working with the stability analysis in AVL. And one last thing to discuss before we go is, if we go back to the geometry design window, here in the help file, you can go on mass file help, and you can view additional information on how you can design or define other options in the mass input file. Something else that we did not include in this is you can also add information on scaling or shifting the points. For example, in this sample that is provided in the help file for AVL, you can see that if a line starts with a star or asterisk for multiplication and the plus sign for addition or offsetting the points, you can add the following points with those operations to scale and offset the values that you have. This is a more advanced feature to use if you are running or you want to include in your design. However, in most cases where you're working with simpler designs, you do not need to include these multiplications or manipulations of the mass and inertias that you've included individually for your aircraft design. So there's additional information here for you to read, and that is all that we needed to discuss for the AVL mass files.